that to their predictions. And it should, hopefully, like here, we predicted that it would be, that they should come up 1/2. So 1/2 big A, little a, and 1/2 little a. So this is spiny and smooth. Okay? And then that's our prediction. So did that come out with your actual results? If they say no, it didn't, well, what could be a possible explanation why it didn't come out to what we predicted, the probable outcome? Think about lab last week. This is a probability. And so what could be a potential problem with our data set? Law of large numbers. Okay? So if they were to randomly do this, if we had time, 100 times for each trait, then they would see that it would come, to what they predicted. Okay? All right, so they do that. Now the last part. I know it's a lot of you guys in this lab going through this with this lab. Because the first time that we did it and, gave them 15 minutes and just walked around, the students just stared at the stuff and I don't even know where to start. So we really have to kind of give them guidance. All right, so for the final part of this lab, now we're looking at, and this is number 2, okay, here. It says, some of the dragon breeders suggest that it would be useful to predict ratios of 2 traits as both may be desirable in a dragon. So can you figure out a way to predict the ratios of the following combinations? So I'm going to ask half of you to try and work on A and half of you to try and work on B, okay? Now notice that some of the sticks, the sticks do have 2 characteristics on them, and so think about that when you're going through this. And then just give them about, I would say, 5 minutes to kind of brainstorm it, because they're probably not going to come up with it. But we're trying to introduce a dihybrid to them here. And okay, so you guys struggled around with that. So let's look at let's look at A first. So 2 characteristics. So if I were looking at, okay, let's say that I want people that are going to have, they want dragons that are going to have, they don't care about anything except they want dragons that are going to have long horns and spiny backs. Okay, so that's 2 characteristics. I now got to look to breed at the same thing. Anything else, they're like, whatever, that's a mix, okay, as long as they have long hairs and long horns and spiny backs. So this is 2 characteristics. I have back and I have horns, okay, horn length. So this is trait 1 and this is trait 2. And so for back, let's say that we have an individual that's heterozygous. Oh, shoot, I didn't introduce that term. You can introduce those terms if you want. But, so let's say that I have, here's what my organism is, okay? So we can track this doing a Punnett square to predict outcomes, okay? And, but what we need to assume, we need to make a big assumption here for A. We need to assume that these traits are on independent chromosomes or sticks, okay? Independent chromosomes or sticks. So that means that we got to have, this is what we're assuming, okay, for this one. Okay, that's what we're assuming, all right? Okay. So if this is my, my mom dragon, my mom dragon is big A, big B, little b, and so is my dad dragon. He's also big A, big B, little b. Okay? I'm going to lose the eggs for mom. This is mom. This is dad. Okay? So remember, mom only passes on half, one of each one of the sets. So she can only pass on 1A and 1B to her eggs, because you only pass on half your traits. Half of each pair. So in this case, we have 4 eggs, right? Because she could pass on an egg with a big A and a big B, or a big A and a little b, or a little a and a big B, or a little a and a little b. Those are all the combos, right? Okay, now dad's sperm. So here's Dad's sperm, right? So he can also make 4 different types of sperm. Okay. And again, you can apply this. This is a bigger Punnett square, right? Because we have, instead of just having 2 eggs and 2 sperm, 2 times 2 is 4, we have 4 eggs and 4 sperm, so 4 times 4 is 16 possible outcomes. And so you put the letters back together. Big A, big B, big B, big A, big B, little b, okay? And go through on this. Okay, I'm just going to kind of fill some of them in a little bit here. You could, so you get the gist of it. Oh, I want to get a, I'm just trying to do this to save time. Okay, so here, when you put that all down, if we were to look at the phenotypes of all of these, we would see that, that you can follow the inheritance of 2 traits, and what we find that if we assume that they're on independent chromosomes, then we see that they are inherited separately, okay? So that means that you can get spiny-backed dragons with long horns or with short horns, okay? So here it is. We got spiny-back with long horns, and then here's one. Here's a spiny back with short horns, okay? And here we have a smooth back with long horns, but here we have a smooth back with short horns. So if they are on independent chromosomes, then we can get all of the different combinations, okay? So understanding that, then you can look at what the probability is of getting certain combinations of traits and set your price point. So if you can't guarantee 100%, then you can say based on the probability, and you can set your price point there. But what if our assumption is incorrect? Okay? What if our assumption is that these are not independent, but they're actually on the same chromosome? Okay? So, like that, okay? And so if we make that with another organism that has the same genotype, okay, a mom and a dad, right? So mom and dad, but instead of them being independent, they are linked. So if characteristics of genes are on the same chromosome, then we say that they're linked. And would the inheritance patterns come out differently? Would we get something like this where we'd have all 4 possible combinations? No. If they're linked, then we're not going to get this independent, what we call assortment. Okay? They're not going to assort independently. And so linked inheritance, sometimes there are genes that are on the same chromosome, and therefore those get inherited together, and that's called linked inheritance. Okay?